dx is equal to 5 to the x natural log of 5, and there was something else. Plus 1 over x squared plus 1?
Yeah.
Is that what it was?
Yeah.
It was number 5?
Yeah.
Okay. So a few things. Okay, so separate this. So we're going to multiply both sides by dx. Yeah? So dy is equal to 5 to the x, the natural log of 5 plus 1 over x squared plus 1. All that times dx. Okay, and I'll be honest with you, the easiest way to do, well, then we got to integrate, right?
Yeah.
Then I'll say what I was going to say. The easiest way to do this one is to know your differentiation rules, like the derivative flashcards, okay? Here's why. D dx of 5 to the x is equal to 5 to the x times the natural log of 5. And d dx of tan inverse of x is equal to 1 over x squared plus 1. Yeah? So this one, okay, so this is going to become y, right? Equals, and this one just kind of requires you to know, oh, and recognize, oh, this right here is this derivative, right? And what did I take the derivative of to get this? 5 to the x. So the antiderivative of this is 5 to the x. And the derivative of this is this, so the antiderivative of this one would be tan inverse of x, so plus tan inverse of x, and then we need the plus c, and we're done. That's the easiest way, okay? There's no other way for this one, okay? But there is another way you can see this one, okay? So that's one option, is you just recognize this is the derivative of 5 to the x, and this is the derivative of tan inverse of x, okay? There's no other way for you guys to do this particular one. There is another way you can look at this one, okay? So again, this becomes y, right? You could, this is just a constant, right? And so you could bring this out and go y equals the natural log of 5 times the integral of 5 to the x dx plus the integral of 1 over x squared plus 1 dx. This one is a antiderivative card that I gave you. Do you know what that one is? As an antiderivative?
And that's ln.
No, it's not ln.
It's x.
5 to the power of x.
5 to the power of x over natural log of
So it's like
5. Yeah, so this is y equals the natural log of 5 times this is 5 to the x over the natural log of 5 plus, okay, there's no way around this. You just got to, this is one of them on your antiderivative sheets, okay? And that is tan inverse of x plus c. And then what happens here? Do you see what happens?
They cancel.
Yeah.
So wouldn't that be an extra?
And see how you get the same answer? It's just kind of a couple ways of looking at it. Okay. Anything else? You got it, right? You got to know your derivative rules, okay?
Right.
Yeah.
I have a question on 18 and 19, but just on the domain. I was confused on how you got the domain.
Can you tell me the answer to 18?
Yeah, that one's
Like 18.
Wait, 18.
We can do 18, right?
No. It's just a log.
17, y equals,
10
she's an overachiever.
Ten
She did 18. What?
inverse.
10 inverse. X
Yeah. Plus 2 to the t.
plus 2 to the
T.
t
Plus 4.
plus 2? Like that? Okay. All right. And what originally they gave you dy over dx, right? And blah, 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 blah. And then they told you
Y equals 3 when t equals 0.
when t equals 0.
Yeah.
And that allowed you to get some stuff, right?
Yeah.
Okay. That allowed you to get your C. Okay. It goes to the domain of this.
Okay.
Okay, so what's causing problems is this one. What's the domain for tan inverse? So remember, for tan inverse, we can only look where and where?
First and fourth.
First, when the ratio is positive, right?
Fourth.
And fourth, when the ratio is?
Negative.
And we can't look at it at pi over 2 or negative pi over 2.
It's actually 10.
10.
10, the inverse is not x, it's t. Yeah.
Okay? Like that, right? Okay. So for tan inverse, we're in these two quadrants. How do we describe these two quadrants? Well, it's everything between negative pi over 2 and pi over 2. That's the domain for this.
So that's how you get the next one then. Because
Yeah.
it was secant t.
So negative pi over 2 to pi over 2. Yeah.
Is it always going to be like that?
Yeah.
Because you can't give you one and the other quadrant.
Yes. Yes. Yeah. So the domain for tan inverse is always negative pi over 2 to pi over 2. Wait a minute. Wait.
No, see?
Wait a minute.
Wouldn't it be 0?
Wait a minute.
0.
I'm totally wrong.
Wouldn't it be like negative pi over 2?
I'm totally wrong.
Okay, okay.
He keeps doing it.
I don't trust you.
I just
Oh.
yeah. Okay. Sorry. That's actually the range.
Right.
So
Oh.
The domain is
Infinity.
negative infinity to
Positive.
positive infinity.
Because it's going up. No. Right? Yeah.
Yeah. Yeah, because the graph of tan inverse does this. It's between negative pi over 2 and pi over 2.
Right. What's going on?
But and it has a horizontal asymptote. Right. I'm sorry. I was doing the range there. Okay, negative pi over 2 to pi over 2. And this is negative infinity to positive infinity. What's the same answers?
It's like that.
Negative pi over, that's wrong.
So what about secant?
So it should be negative infinity to positive infinity. Okay. Secant.
It should have secant and then plus
E to the t is not going to be a problem, right? Because you can plug anything in. There's no domain restrictions on exponential functions. It's secant?
secant t. It's for secant t.
For secant t? Okay. So what that was 19?
Yeah.
So your answer was y equals 4 secant of
T
t plus e to the t
plus 3.
plus 3. And then what?
3t squared.
3t squared. Okay. This is not going to cause problems. This is not going to cause problems for domain. This is, right? The secant. Because that's 1 over cosine, right? So whenever cosine t is 0, right? So when is cosine of t equal to 0? And this isn't secant inverse. It's just secant, right?
Pi over
Okay.
2. Pi over 2.
Pi over
2.
pi over 2.
3 pi over 2.
3 pi over 2, negative pi over 2,
Negative pi over 2.
yeah, negative 5 pi over 2, negative 3 pi over 2, right? All of those, okay? What was the initial condition that they gave you on this?
Well,
Equals
it's-
5 when t equals 0.
Y equals 5 when t equals 0? Okay, so this one is in between negative pi over 2 and pi over 2, right? So this one's domain is negative pi over 2 to pi over 2. Because there's a lot of these, right? So dot dot dot, negative 5 pi over 2 to negative 3 pi over 2. Negative 3 pi over 2 to negative pi over 2. Negative pi over 2 to pi over 2. Pi over 2 to 3 pi over 2. And so on, right? So that these are all like little individual domains, right? Which one includes this one t equals 0? It's that one. That's why I picked that one, okay? It has to be the piece that includes your initial condition of t equals 0. Okay? All right? Okay. Let's get going on the assignment today. This is going to come back. All this stuff is going to come back right here on day 6 of this unit, okay? I didn't pass out the notes, huh?
No.
No, one short lesson. Short lesson.
Yeah, so we call
It's not.
It's love.
It does look like, I think it does look like connect the dots. Just this bag is scary. Look at the bag.
Sorry for medical back brace. I think I'm crippled or something.
Oh, good one.
We can give you a free medical back brace.
That's scares me.
That's the one.
Back brace.
Oh, I didn't get one. That's a no good. I didn't get one.
Yeah, but not right now. I don't think you went today.
Good as ass. Oh, no, dude.
Okay. Okay, what I have here is okay. So you guys yesterday you guys were finding particular solutions to these differential equations, right? And then you had a general solution. We talked about that, and we talked about particular ones, right? So here's a differential equation. And what this is all these little points are all particular solutions, all right? And the general solution is like all of these, right? The plus c. Yeah? That's all of these. Okay, so you can write all of these functions one way with the plus c, and you just add different constants, and it causes different particular solutions, okay? All right, so here I'm going to show you. This is called a slope field, and what it does is it helps us see the pattern to all of these particular solutions, like all of them. Okay, it's really not all of them, but it has you get a flavor of like what all of them look like just from something like this. I'll explain how to draw this later on. Okay, but let me switch over to my program here. Okay, just a regular old x and y axis, right? And I'm going to go y equals, and I'm going to put in a differential equation, y prime is equal to, and I'm going to put this one in that we have on our paper, x plus y. Okay? And what these are little slope lines. Oh, I thought I had a little laser on this.
The laser doesn't work on the TV.
It doesn't.
Well, I don't think so.
Never mind. Yeah, I got these. Got old tech. Okay. So, so what this is this is the slope at like right here. This is the slope at 1, 1, and it's a positive slope right there, right? And so you're not going to draw the whole entire line. You're just going to draw a little part of it. Okay. So the slope at the point 1, 1 looks like it's about like 1 or a little bit higher than 1. Okay. Right here looks like the slope is 0. Right? Why do I say that? Because it's horizontal, right? I don't see any verticals. That would be where the slope is undefined. Okay? Yeah? And so what I can do on this is I can click on one of these slope lines for this program, particular program, okay? I can click on one of these slope lines, and there's a particular solution. Here's another particular solution. This is a particular solution at -3, 1.5. So this is the solution, the particular solution when y is 1.5 when x equals -3, like I was telling you yesterday, right? So that's it right there. You would have come up with this equation if you had done this one. Okay? Here's another one. Here's another one. Here's another one. And I can just click on these, click on these, click on these. Thank you. Click on these, click on these, click on these, click on these. Okay, so you notice they're all converging like right in here, huh?
Yeah.
They're all coming together. That's like an asymptote. Okay, so this like differential equation would have an asymptote, a type of asymptote. Okay, get the idea on this? And these are like I'm showing a whole bunch. Everywhere you see a point, that's a particular solution to this differential equation. Yeah? Okay. All right. So what I want to do is on this one, let me switch over. We're going to draw in freehand, okay, a slope field for the difference equation dy over dx is equal to x plus y is shown below. Sketch a particular solution that passes through the point 2, 0. So this is like a current to a river. You've got to go with the current. Okay, you're drowning and you just got to go with it. All right? Actually, not drowning. Maybe that's bad. You don't want to fight the current because you'll wear yourself out, right?
Yeah.
So you just got to kind of go along for the ride, keeping your head above water, right? So you don't drown, okay? All right? Okay? So what happens here is you got to use these slope lines as a guide to graphing this. So if you're cutting across, going like against the grain, that's another way of saying it. If you're drawing it out this way, you see how you're going against these slope lines? That'd be wrong. Okay? So there's not really one right answer to this, but there could be some wrong answers, okay? All right? And you just got to kind of let yourself be guided by these slope lines, okay? So something like this would be right for that. Okay? Now I can keep going, right? Because I just did to the right of 2. I'm also going to go to the left. Now, do you see what's happening to the left? It's kind of starting to curve down, right? And then flattening out. And then it looks like it's going towards this horizontal, or not horizontal, this asymptote right here. And really, the only thing that could be wrong is if you just cut across the slope field, okay, or slope line. Okay? And your graph should look something like this when you do this. You okay? Make sense? Okay. That's one type of problem I'm going to ask you to do. Okay? Next type problem. Un momento. Now I know what just happened.
En el taller que hicimos, ustedes pusieron que sí era bueno aprender, porque no.
Okay. What we have to do is match the differential equation, these four differential equations, with these four graphs, okay? Now, what we need to do when we're doing this is to consider where dy over dx is equal to 0. What causes dy over dx to equal 0? Because where dy over dx is equal to 0, you're going to see a little slope line that is horizontal. Okay? So that's one way to distinguish one from the other, okay? What causes the dy over dx to be 0? Okay? And the x and y combination that causes that to be 0, you should have little horizontal slope lines there. Okay? dy, we should also think about dy over dx as undefined. Okay? When it's undefined, that would cause a vertical slope line. So look at the x and y's that cause it to be undefined. Okay? You could also look at dy over dx is equal to 1. If it's equal to 1, that just means it has a positive slope and it's like at a 45-degree angle to the horizontal, so it looks something like that. That's hard to tell between a slope of 2 and a slope of 1. Okay, so that's why this is like last-ditch effort. These are easier to see. Okay, you could also consider dy over dx is equal to -1, which would be the same thing, but just going down, right? And if all else fails, plug x and y coordinates in. Like plug an x or a y in to see what happens, okay? So plug x, y in. That's another option for you, okay? Okay. So dy over dx is equal to x minus y. Let's match that one first, okay? So let's consider, okay, what causes dy over dx to equal 0? Well, since dy over dx is equal to 0, that would mean x minus y would have to equal 0, which means x is equal to y. So wherever x and y are the same, you should see a little horizontal slope line. Okay, so give me x and y's that are the same. Like a point where x and y are the same. 1, 1. 3, 3.
-3.
-3. -3, right? So let's take a look at this. Okay, 1, 1. That would be right here. I am not seeing a horizontal slope line. Do you guys see that? It's not there, right? So I would say this is it. Right off the get-go. Even 2, 2. 2, 2 is right, looking at this one right here. That looks more like a slope of 1. Right? Okay. How about over here? 1, 1 on this one. That one kind of looks like a slope of 1, 2, right? 2, 2.
Yep.
2, 2. That looks even steeper, right?
Yep.
Than 1, 1. So I wouldn't say it's this one either. How about this one, bottom left? 1, 1. Hey, that looks horizontal. 2, 2.
Yeah.
Hey, 3, 3.
Yeah.
Hey, 5, 5. Hey, getting excited here. Looks like it might be the right one. -2. Let's do -2, right? -2, -2. This, I think this is it, right?
Yeah.
But we haven't looked at this one, right? Okay, so let's look at 1, 1 on this one. 1, 1.
No.
No. So this is the only one where that's happening, right? So if like both these were happening, that was happening at, we'd have to like you go to something else, like where it's undefined or something. Okay, you get the idea? So this one right here, we've narrowed it down. This one has to be the dy over dx is equal to x minus y.
Mm-hmm.
Okay? Now we've got 3 left, right? Okay, so back up to this next one. Dy over dx is equal to x times y. Okay, let's again consider, where's dy over dx equal to 0? Well, that's going to happen when either the x or the y is 0, right? So x is equal to 0 is going to give me a horizontal, and also y equals 0 is going to give me a horizontal slope line, right? What does x equals 0 describe? X equals 0 describes something.
The slope.
The axis?
Which axis?
One.
That's the y-axis. X equals 0 is the y-axis. Y equals 0. Where's y equals 0? On the...
Y-axis.
So this is describing the x-axis. Okay, so this is basically telling me I should look on the x and y-axis, and we should have horizontal slope lines on both the x-axis and the y-axis. Okay, so look at the y-axis right here. These don't look horizontal, they actually look vertical. The x-axis looks, that one looks horizontal, right?
Yeah.
See how these are all kind of flat
Yeah.
on either side? Okay, so it's not this one, right? Because the y-axis, we don't have horizontal slope lines. How about this one?
That one is
Yes,
for
no.
horizontal.
So the y-axis has horizontal slope lines. The x-axis also has horizontal. So I'm thinking it's this one.
Same.
Okay. So we haven't checked this one yet, right?
Yeah.
So okay, the y-axis. Yeah, the y-axis has horizontal slope lines. X-axis. So I don't think it's got to be this one then, right?
Yes.
Okay. So this one has to be dy over dx is equal to x times y. Then we go to this one, dy over dx is equal to x over y.
It has to be in the front.
So dy over dx is what causes the derivative to be 0?
One. I mean,
Yeah.
Only
equals
when
0.
x is equal to 0, right? When the numerator. So that's going to be when x equals 0, we would have horizontals, right?
Yeah.
And x equals 0 describes
No way.
y-axis. Yeah?
Yes.
Okay, for this one, we can also talk about undefined, right?
Yes.
So dy over dx is equal to undefined when
Why?
y equals 0. And when it's undefined, the slope would be vertical. And y equals 0 describes the x-axis. So basically, okay, the y-axis has to be horizontal slope lines, and the x-axis has to be vertical slope lines. Well, we've already picked these two, so we're narrowed down to these two, right? Okay, so x-axis, or y-axis needs to be horizontal. On this top left one, it's vertical, right? Okay, and x-axis is horizontal, and it should be,
No, wait. X-axis is
x-axis is horizontal, but it should be vertical to match this, right? So this one, okay, what do we say? The y-axis needs to be horizontal, is it?
Yes.
X-axis needs to be vertical slope lines, is it?
Yes.
Yes, that's it, right? So dy over dx, for this one, dy over dx is equal to x over y. Now, I do realize we only have one differential equation left, and we only have one slope field left, so it's got to be that one, right? But let's still go through the analysis that it confirms, yeah, right? That it matches. Because you may get on the multiple choice test, none of these,
Oh, yeah.
right? That'd be mean, but okay. So dy over dx, let's take a look at this one. Dy over dx is equal to 0. It'd be equal to 0 when the numerator is 0, so that, or y equals 0, and that would cause a horizontal tangent, or not, yeah, horizontal tangent, right? So horizontal slope line. And that, what does y equals 0 describe? x-axis. So we should be looking at the x-axis and we should have horizontals. Where is this one undefined? That would be when x equals 0, and that would be vertical, and that x equals 0 is the y-axis. So on the y-axis we should see verticals, which we do in this one, right? And on the horizontal axis, the x-axis, we should see horizontals, right? And we do. So that has to be this one then, right? So this one has to be dy over dx is equal to y over x. Okay? You could also do it like this. Okay, let's put the point 5,5 in here. Right? 5,5. That'd be x is 5, y is 5, right? That would give you a slope of 1. Look at 5,5. That gives you a slope of 1. That's what I mean by plugging numbers in. If you last ditch effort, just start plugging numbers in and see. And I would like plug numbers in each of the 4 quadrants to help see what's going on, okay? Okay? Because this makes sense. Why in this quadrant are all these slopes positive? Because in that quadrant, x and y are both positive, right? Which is going to cause this derivative to be positive. Over here, why are they all negative?
Because x and y are there.
Because x and y, one of them is negative, one of them is positive. When you go to divide them, it's going to give you a negative, right? Same thing here.
But that's positive because
Oh, sorry, positive.
both are
Both of them.
negative.
Both are negative, which when you divide causes the positive, right?
So you always plug in the same number.
What do you mean by the same number?
Like 5,5.
No, it could be, no, it wouldn't have to be 4,2. You know, 4,2.
5,
And just take a look at what's happening at 4,2.
2, 7.
Okay. You can use that to tell, wait, it's supposed to be positive and it's negative. Like, use it for that sake. Okay. All right. You okay? All right. And then the last thing I want you to be able to do is construct a slope field. Okay. Now, I would take a look and look at this. Okay. When would this derivative be 0?
When x equals 0.
So I would use that to my advantage. dy over dx is equal to 0 when x equals 0, right? And x equals 0 describes the y-axis, right? And so it's going to be 0 when, and you're going to have a horizontal tangent, right? So the y-axis, this y-axis right here, because we have 12, you guys realize we have 12 points to do? Okay, so you can use this to help yourself out. You know you're going to draw little horizontal slopes everywhere x is equal to 0, which are these 4 points. So grab a ruler, and what we're going to do is we're going to draw little slope lines
Sorry about that.
for each of these. You are not allowed to use a ruler on the AP exam. I would use your test booklet. Or something straight.
ID card.
No, I'll talk about what they would dock points off on in just a minute, okay? Okay? You alright with all that? Okay. Now, I didn't ask you to do this, but we'd have vertical slope lines when?
Y equals
When
negative
y equals -2, but you like the
There is
vertical?
no negative.
Go backwards. No, I don't want to go backwards. My back's just fine. I know I'm old, but geez. All right. Okay, so when y equals -2, it'd be undefined, which means we'd have vertical, but I don't go down to y equals -2, right? So no point in doing that, okay? Make sense?
Yes.
Okay, so what we have to do is go through we gotta do these 4 points and these 4 points and just put them into the derivative and see what kind of slope we get, okay? So dy over dx, let me do this side. dy over dx at, let's do the point 1, 2. Remember, that's the way to write it, putting 1, 2 in. I would definitely write this notation because then you know which one you're doing here, okay? So this would be, okay, so x is 1 over 2 plus 2, and that would be 1/4, right? I wouldn't do that yet. I wouldn't graph it yet. Hold on. Let's do all 4 of these, and then I'll talk about what they're looking for, okay? And then let's do the next one. So dy over dx at the point 1, 1. That would equal 1 over 1 plus 2, which would be 1/3. dy over dx at the point 1, 0. That'd be 1 over 0 plus 2, which would be 1/2. dy over dx at 1, -1. And that would be 1 over -1 plus 2. That'd be 1 over 1 or 1. Now remember, these are slopes, right? So this 1/4 means up 1, right 4. 1/3 slope means up 1, right 3. 1/2 slope means up 1 and right 2. dy over dx is slope is 1 over 1. That means up 1 and right 1. Which is the steepest?
So that 1 over
The steepest means
1,
that's straight
1, 5.
1 over
1, 1, right?
Yeah.
This is the steepest one, okay? So that's happening at 1, -1, right? So what I would do is, okay, so that's happening right here. I would go up 1, and we don't have a space to go over 1, right? So you're just gonna kind of eyeball it. Right about there would be where the next one is, right? And just use a straight edge, use a piece of paper or something that's straight, and just draw in your little slope line right here. The next one has a slope of 1/2, so that means I'd have to go up 1 and right 2, and just kind of eyeball it. Right about there. You could also go down 1 and left 2. And that would give you this point right here, right, to use. So you can do it that way too, okay? The next point, 1, 1, would be 1/3, so up 1 and right 3. So 1, 2, 3. Or you can go down 1 and left 3. It's like math 1 all over again, huh? And the last one is 1/4. And okay, so this time I'm not going to go up 1. I'm running out of space on my paper right over here, right? So what I'm going to do instead of going up 1 to right 4, I'm going to go down 1 and left 4. So 1, 2, 3, 4. It just has to be close. They're not looking for perfect. They're not going to judge you on the perfect slope. Okay? So let me tell you how they're going to grade you. And this is how I grade you on the next test. Because I ask you to do one like this. Okay? All I'm doing, I'm not looking for this is perfect slope of 1. And this is a perfect slope of 1/4. I'm not looking for that. I'm looking for, are these all positive slopes? And this one's the steepest. And then as I go look my way up, these are getting less and less and less steep. That's all I'm judging you on. Got it? That's how they judge you too. Okay? It's relative. Okay, is this the steepest? It's just relative. Is this the steepest of these 4? That one's the steepest. And as I go up, they get less steep. That's all I'm looking for, okay? If you do that, I'm a happy teacher. Okay? Now we need to do these 4, right? So dy dx at the point -1, 2. And that would give you -1 over 2 plus 2, which would be -1/4. dy over dx. And if you can do this in your head, I'm okay with that. Not everybody can hold these, put 2 numbers in and hold it in your head. Okay, dy over dx at -1, 1. That would be -1 over 1 plus 2. Now maybe you can do that in your head. 3. dy over dx at -1, 0 would be -1 over 0 plus 2, that'd be 2. I'm not going to look at your work on this, okay? Like when I'm just going to judge you on your drawing of this, okay? dy over dx. So you show as little work or as much work as you want. -1, -1, that'd be -1 over -1 plus 2, which would be 1. And this would give you a slope of -1. And again, of these four, which one's the steepest? -1, and they're all negative, right? So I'm going to be looking. Is all four of these going down, right? Left to right, going down. Okay. So this one, -1 would be something like this. It'd be parallel to a line going through these 2 points, right? Do you guys see that?
Oh.
Okay. So you can do it that way. There's my first one. This one's going to go from this point, -1, 0. I'm going to go down 1 and right 2. So I'm going to line up these 2 points right here and use those to help draw it. I'll let you use a ruler on the test, okay? And then -1, 0 is -1/3. So down 1 from this point, go down 1 and right 3. And that'd be this point. So I'm going to line those up. How long you make these doesn't matter. Okay? Make them long enough so I can judge the steepness of it, okay? All right, and then this last one is -1/4, so down 1 and right 4. So that'd be like this point right here. Okay, so let me tell you, you're making it really hard for me. You're making it hard for me to grade you. Don't do that. You see what happened? What's wrong with that? Make it long enough so that I can see it, okay? Got it? That's not long enough to, that's gonna be hard to, if I'm judging, is this one less steep than this one? You're making it hard to judge. Right? Don't do that on purpose either, because I'll mark it wrong. Okay, so just make it doesn't have to be super duper long, but it needs to be long enough so that I can compare them, okay? And sometimes it does get hard, like these two are hard to tell the difference between, right? It is. I get that, and so I'm not going to judge you too harshly on this, okay? But I should see these two being the same steepness, right? Because those are definitely different, okay? All right? And to me, they do look like they're getting less steep. It's just, 1/4 versus 1/3 is hard to tell the difference, for steepness, okay? All right? Not too bad, right? Yeah. When you look at this, when you look at the first page of notes, it's like, oh my gosh, what the heck? It's not that bad. It's all right. So was it hard? Yeah, it's not hard. It's not hard. Okay. All right. Couple things I want to point out on the homework. Okay. You have some in the book that I want you to look at, okay, and you got to do some analysis to figure out which one's which. It's like 4 differential equations and then four graphs, okay, and then you get into 29, okay, and that's where you have to start drawing them, okay, and then these 6 right here you need to match, okay, and then you see these points. They're asking you to draw a particular solution for all of these. Draw the particular solution that goes through 3, 2.
Oh.
So see that point right there? So I want you to draw the particular solution that goes through those, okay? So do that. Match it, and then graph one of them. Graph the one that goes through that point, okay? And then if you flip it over, these are a little harder, okay? Same thing, okay? Matching, all right? But these are a little bit harder. You've got absolute value going on. This one only is determined by your x, right? And you're square rooting it. So what I would do for this one, it's going to be really hard for you to do the analysis of where it's 0. I would plug points in. Plug different x values in and see what happens. And for this one, for 42, plug in different y coordinates. This is only, there's no x and y, it's just the y. It's just the slope is only determined by your y on this problem. So you just plug a y in and see, kind of try to figure out what's going on, okay? Those are probably the last two you'll do. You'll probably do these 4, match them, and then you're left with 2 of them, and then you're going to use, points, plugging points in to kind of determine which one's which. Okay, that's what I would do. All right, you good? This is usually on the multiple choice section of the EP. Like, here's this differential equation, which is the slope field. Okay. All right. That's it. Tomorrow, be here if you can. Okay? It's integration by substitution. It's a new technique that I'm going to show you.
Yes.
Okay? And we're going to start really slow, simple ones, and then we're going to build. And it'll make some of the problems that you did yesterday easier. Some of them. Okay?
Yeah.
What's that? Oh,